First of all, I give thanks for life. Yeah, I thank the Father for blessing.
Welcome again, everyone, to another video. I am Daryl Barrow, Chief Audio Engineer here at BEXtronics, and in today's video, we are going to talk about noise reduction coefficient. Noise reduction coefficient is the brother of the SDC rating. SDC rating, as we learned in a previous video, is the ability of a construct to stop noise transfer through it. Noise reduction coefficient, on the other hand, is the ability of a material to absorb sound. All right. So if we look at what is NRC, or noise reduction coefficient, is a value given to a material on its ability to absorb sound within a room. NRC frequencies, or the testing frequencies that are used to give the NRC value, is based on a frequency sample size of the standard being used. And the standard being used, it's if it's an ASTM standard and which value it's being used. So it's a very wide range to determine the NRC frequencies. The NRC value is scored from 0 to the number 1. And that is because 0 means it absorbs 0 sound. The number 1 means it absorbs 100% of sound. Here we are on the whiteboard, and here we have our room. And if we were to draw some acoustic panels in our room, so let's just draw 2 acoustic panels on this wall of our room. Now, what happens is, if we take our sound source, which would be a speaker right here, and it emits sound, what happens is the sound is going to hit this panel, and some is going to be reflected back. This here outputs 100% of sound. The amount of sound that these panels here absorb is what gives our NRC value. So let's say that these panels absorb 75% of the sound. Then these panels are said to have an NRC rating of 0.75. How much percentage of the sound it absorbs gives its NRC rating. Alright, so we are back on the presentation, and let's go through the limitations of the NRC. Sometimes you may see an NRC with a value over the 1.0, maybe a 1.05 or 1.08. That's because due to the calculations they use, it's easy to manipulate the data to give you a value over the 1.0. This is just a marketing ploy, right? Which brings me to my next point. It's impossible for a material to absorb more than 100% of sound, because we said the 1.0 is equivalent to 100%. So given that an NRC cannot be more than 100% absorption, you can easily see why the 1.05 and the 1.08 NRC values are absolutely incorrect. And an easy way to think about it is if you build a fish tank out of sponge. Let's go to the whiteboard and I'll explain to you what I mean. And we have our fish tank here, and our fish tank here is built out of sponge or sound absorbing material. The most common one is acoustic foam. So we have our fish tank here built out of acoustic foam, and we're going to fill it with water. What's going to happen is, as the water comes in, it's going to absorb into the sponge, but after a while, all the water will just simply come out. That's because the sponge has absorbed all the water it could. Now imagine the water is sound. The foam will absorb some sound, but it will not be able to absorb all that sound, which brings to the last limitation of the NRC. Alright, so we are back on the presentation, which brings to the last point. The 1.0 NRC value is usually at 1 frequency, maybe 2 if you are lucky. So when you see a material gives you an NRC of 1.2, you need to read its frequency analysis charts and see what it's really absorbing. Alright, I hope this helps. Again, for BEXtronics, I am Daryl Barrow. Hope this video gave you some insight into the noise reduction coefficient, and I hope to see you again in the next video.
First of all, I give thanks for life, yeah. I thank